theoretical probability. So that's probability based on mathematics. So like in this case here, let's use this as an example. We have a spinner with 8 different choices here. And let's say it's symmetrical. So each little space is the exact same length, so they're all the same probability. So if I ask, like, what's the odds of hitting a 2? Well, yeah, there's 1, 2, and there's 8 choices. And since they all have the same probability, it'll just be 1 out of 8. That's what happens anytime you have equally likely occurrences, 1 out of the total amount of things. So that's based on the mathematical probability of it all. In general, just like when we do experiment probability, it's going to be 1 over total. So if you want the probability of A, it's mathematically the number of times the thing you want could happen over the total amount possible. So it's still going to be want total. So let's do an example. A ticket is randomly selected from a basket containing 3 green, 4 yellow, 5 blue tickets. Determine the probability of getting a green ticket. So let's do A, probability of green. So first we got to figure out what the total is. Our whole universe. So you have 3 green, 4 yellow, so that's 7 plus 5 is 12. And then I just want to go, the odds of getting a green ticket would be the 3 options of green over 12. I want green, there's only 3 green, and the total is 12. So 3 out of 12 or 1/4. B, a green or yellow ticket. So green or yellow. Now we can use the formula for the or, but in this case it's just green or yellow, so it's either or. So I'd be happy with getting green or yellow. So that's 3 plus 4 over the total of 12. So 7 over 12. C, an orange ticket. There is no orange ticket. So probably getting orange would just be 0 over 12, which is 0%. Not going to happen. A green, yellow, or blue ticket, well, that's any ticket. So in that case, my probability is just going to be 12 over 12, or 100%. So that's the idea. It's 1 over total. What are the odds? How many items do you want to get? Are in the selection of things you want to get over the total number of items. So it's another one. An ordinary 6-sided die is rolled once. Determine the chance of getting a 6 first. So if you roll a 6-sided die, so you could get a 1, a 2, a 3, a 4, a 5, or a 6. There we go. Right, so you have 6. So my total was 6. I have 6 different possibilities. So probability of getting a 6 will just be, well, there's only 1 6, so 1 out of 6. Not getting a 6 versus the complement of getting a 6. Remember, the way that works is, if you add up the probability of event plus probability of not doing that event, it should equal 1. These two together should add up to 1. And we mostly use it as this. If you want to find the complement of something, it's just 1 minus the odds of that one thing happening. So if I want to find not getting 6, that's just the same thing as saying 1 minus probability of getting a 6. Which we figured out was 1 over 6. So it's just 1 minus 1 over 6, which would get me 1 minus 6 over 6 minus 1 over 6, or 5 over 6. Now, or you can say, what's the odds of not getting a 6? Look at my choices here. There's 1, 2, 3, 4, 5 things that are not a 6, so it'll be 5 out of 6. Right? That seems easier now, but there'll be problems where doing the complement is so much easier than doing the direct version. So it's always a way you can do it. If you see not getting this number, you can always do 1 minus getting that number. And the next one, getting a 1 or a 2. So you want to get a 1 or a 2. So there's 2 of those out of 6. And then not getting a 1 or a 2. So I can just do 1 minus 2 over 6, which gives me 4 over 6. Because it's a common denominator. Okay, once again, so hopefully a little easier. Next one. Use a 2-dimensional grid to illustrate the sample space for tossing a coin and rolling a die simultaneously. Hence, determine the probability of this. So first we're going to do a 2-dimensional grid. So here's coin. And we're going to do tossing a die. Now it doesn't matter which one you do which, like which axis you do which on. So if you toss a coin, you can do heads or tails. When you roll a die, it could be 1, 2, 3, 4, 5, or 6. Remember, the things you could hit are these things, where they intersect are your choices. So we should have 12 choices here. Oh, yeah, 12 choices. Hence, determine the probability of tossing a head. Well, that happens here, so that happens in 6 out of the 12. tossing a tail and rolling a 5. So here's tails, here's rolling a 5, right? So this guy right there, it only happens 1 out of my total of 12 times. Again, 12 is just count up all these highlight spaces, these intersections. There's 12 intersections, and tossing a tail and rolling a 5 only happens at one of those intersections. Tossing a tail or rolling a 5, or rolling a 5. So again, when I say an or, I'm always tempted to use the formula. Tail or rolling a 5 is the probability of tails plus probability of rolling a 5 minus what they have in common. So to me, it's the easiest way to do it when there's an or most of the time. Probability of rolling a tail, well, again, look at here. There's having 6 times out of the total of 12, so it's going to be 6 out of 12. Possibility again of rolling a 5, well, that happens twice out of the total of 12, so 2 out of 12. And then what do they have in common? Tossing a tail and rolling a 5. So tail and 5, that's 1 out of 12, which we already had, which we figured out earlier. And you do math on this, 6 plus 2 minus 1 is 7 out of 12. So having 7 out of 12 times, you could either toss a tail or get a 5. Remember, it's an or, so I could get it, toss a tail or get a 5, I'm not happy. Do it, if you want to do it just with using the diagram here, so you toss the tails, you're good. So toss tail, toss tail, toss tails, or roll a 5. So that happens and it happens there. So if you count them all up, you get 6 plus 1 is 7. So 2 ways to do it, right? You could do it using the formula, or if you have a grid, you just count them up. So tossing tail and rolling a 5, how many things do you count? 7 out of 12. Next one. Display the possible returns when 2 die are rolled and the scores are added together. Hence, find the probability that the sum of the die is 7. So that's probably the easiest way to do this is by doing another two-way table. Not two-way table. What's it called? A 2-dimensional grid. So we have 1, 2, 3, 4, 6, which is die 1. Let's do die 2. 1, 2, 4, 5, 6. Like that. Now, so all these intersections are all the possibilities you could get. So it's 1, 1, 1, 2. There's 36 in here because it's 6 times 6. So each one of these is what you get. Now, what they wanted us to find the sum of the scores added together. So if I could help us out here. 1 plus 1 is 2. This is 3, 4, 5, 6, 7. 2 plus 1 here is 3. This is 4, 5, 6. Right, so I can fill out the rest of it doing this way. I'll stop boring you by actually counting. Let me finish the rest off camera. And we're back. Right, so I filled it all out off camera. Now remember, the total is 36. You could do look at it by going 6 times 6. So 1 over total. My total is going to be 36. And what do we want? We want the number to get 7 as a die roll. So it happens here, here, here. It happens 6 times. So 6 out of 36, or 1 out of 36 chance. So those are odds of rolling a 7 when you throw a die. 1 out of 6 chance. Next one. In a Venn diagram, the universal set is the children in a class. Each dot represents a student. So here we go. So these are all students in the class. The event B is that the student has blue eyes. It's a lot of blue eyes. Find probably that a randomly selected child has blue eyes, doesn't have blue eyes. So first we gotta find the total. Right, so we're just doing a Venn diagram. Looks like there is 8 people in here. And there's how many in here? 4 times 3 is 12 plus 3, so 15. So my total is 23 students. How many of them have blue eyes? So it looks like we have 8 out of 23. And then does not have blue eyes. So again, there's only 2 options here, so these have blue eyes, so not have blue eyes would be 15 out of 23. But you could also, again, if you wanted to, you could also have done 1 minus the odds that they have blue eyes. And then just done the math. So 2 ways to get it. In this case, you have Venn diagram, just go to the Venn diagram. Okay, next one. In a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both subjects. Display this information in a Venn diagram. Ooh, it's been a while since I've done a Venn diagram like this. So here's my Venn diagram. The universe has 30 students. It looks like we have physics, chemistry. And what did they tell us? 19 study physics. So all of this is 19. Keep in mind that is not this circle, right? It's the whole circle is 19. 17 study chemistry. Same rule. This whole thing is 17. And 15 study both of these subjects. So that one I could fill in. That is 15. And that's kind of the key to the whole thing. If I have that, I could pretty much fill out the rest. So this is 15 because that's both study. That means the number of people that take physics but don't study chemistry is 4. And likewise over here, this whole circle is 17, but there's 15 in there, so it's 2. If you want to find the outside, well, I know all this should be 30, right? Because that's what this is. How much do we have together in here? We have 4 plus 15 plus 2. So we have 21. So that means there's 9 people that don't take either of these classes. So 9 by neither. Once you fill out this Venn diagram, the rest is pretty easy. Hence, determine the probability that a randomly selected student from a class studies both subjects. That would be the 15 out of the possible 30. Two. At least one of these subjects. At least one. So at least one means one or both. So it's all this part right here. So 4, 15, and 2. All this is at least one. You can study this one or that one. It's one or more is at least one. So we're going to have 421 over 30. We did that. We added all that up before right here. Physics but not chemistry. So they want to take physics but they don't want any part of chemistry. So that's only these people right here. So 4 out of 30. Hence, notice, also by the way, notice how they say probability, so I'm always dividing by the total amount, right? It's 1 over total. Exactly one of the subjects is this one, like only physics, and this one, only chemistry. So 6 out of 30. Neither subject, the people on the outside here, 9 out of 30. Remember, the way I got the neither was I added these guys up and I subtracted from the universe. So I got the neither. So there's that one, and that is it.